17 weeks. I think 17 weeks. The same.
Somebody's
not here today, so.
Yeah, in 3 years we have.
I was wondering why that phone was there.
Oh, yeah, holds that thing down. Okay, well, I guess we should be getting started. It's a couple minutes after, so high time it is. So here there's something funny about the homework, and that's the usual case. So homework 3. It says to go to home data somewhere. Yep, home data, okay. Oh, and then starts talking about diffusion tensor images right away. Okay. Well, I suppose this should probably say to change directory right here. And luckily we can fix that quite easily. Oh, I'm going to try something else. This might make a recording of everything I type up here. Or it might not work right, we'll see. Trying something new. Okay, so in order to edit the assignment, I keep it in a folder called CS228 and CS228 web. And so here's where, change the color so you can see it. Anything can be changed. And so I guess what I should do is say, there we go. Yeah, very nice. Okay, so everything's edited. And I got to put this where it goes. And so now over here, should be fixed. Okay, so as far as how to actually follow that instruction, if you're on here and you go to home data, I should have these directories in here, including IXI, and there's all the files in here that you can start working with. Okay, so hopefully that makes sense. And sounds like it was something that could be figured out anyway, so that's fine. Okay, so as far as what to talk about today, it's September 9th. Oh yeah, homework 2. This looks like not the right day.
It's 14.
Oh, well we can go continue fixing the website then. Okay, should be under September something else, 14. There we go. Okay, so now we should have September 14. There we go. Okay. Oh, doing a little comment about pipelines. I forgot about this one. So there's some famous artist that may or may not have commented on making stuff out of stones. What do they call that? Carving? Sculpture? I don't know. Anyway, a thing where you make something out of a rock and then you put it on a pedestal and everybody looks at it. And his comment was that you take whatever you're going to make a statue, that's the right word, and you chip away everything that isn't part of your statue, and then you're left with a statue. Simple process, right? Now, I looked around on the internet, nobody seems to know who said that, so that's why I didn't include a reference. So pipes are all like that. If you're on here and you have the output from last, and you want to know everybody who logged in from, say, something on campus. Most of the campus ones have a 10 in it, so you can grab 10. And some of these are good and some of these aren't. Like the 10 dot whatever, that's good. The stuff that has like 172 or whatever, that's probably off campus and just so happens to be there. So let's look for, say, a 10 with a space in front. Okay, there we go, that's a lot better. Now we still got stuff over here on the date, and so 10 with a period is not really going to help. Looks like everybody on campus is 10.1 something. See a lot of that 10.1 something. Okay, there we go. And we're still seeing the occasional thing that's, well, Emily should that's campus. That's actually on campus. But we saw a 10 and a something and then a 1 there. And so we're getting there. We could probably put a slash in front of this and get rid of the ones that don't have like 10.1. Okay, so we kind of got everything out of there, and then we can put this into a word count. And there we go. So we just take stuff and keep paring away stuff that's not part of our results. If we wanted to have on here, say, instead a list of unique users, we could grep for, I haven't got to this yet, but take from the beginning of it a bunch of somethings, and dash O, which you might have discovered last time. That's one too many somethings. There we go. And then sort them, and then get the ones that are unique. And there we have a list of users. And so the question is how many people used it? 34. Okay, so the general procedure here is kind of start off with whatever you're looking at and then just keep chipping away parts that aren't part of your result until eventually you have what you're looking for. Anyway, sorry, minor philosophical point. Okay, I like tangents. Let's go look at homework 2 and the solutions to it. So here's homework 2. And so this first part, you want a list of users who logged in on a Saturday. The main point of confusion I saw on this one was assuming that you had to log in on a Saturday to do this. And that's certainly not true. You don't have to log in on a Saturday. So I was just playing with the output from last year. And what I'm interested in is this column right here, you know, to, wed, etc. And we want logged in on a Saturday. Okay. And so there we go. We have people logged in on Saturday, September 5th and Saturday, September 12th. Probably won't be seeing too many Saturday, September 12th in the homework assignment results, but there you go. Okay, so that works just fine. If you wanted to take a particular day, you know, you could search for, you know, Saturday, and what is that, 2 spaces, 5, and you'd have all the Saturday, September 5th. But you know, you just kind of chip away at this stuff until you get what you want. If you wanted to take it further, you didn't have to do this. This lists all users who logged in on a Saturday, but it does some of them twice. If you really don't like this, you can take the beginning of a line with, as I mentioned, something like that, maybe one more, and then do it dash O, and then sort. There you go. Okay, but that's not part of the homework assignment. Just because otherwise everybody's going to get bored if they got the right answer, so I have to show you something new. Okay, so that was the end. It's a good answer there. Oh yeah, this is poem. Okay, so there's this poem here. How many people read the poem? Not one? Oh, one. Okay, there we go. Anyway, everybody else just text processed it by putting in grep and okay, and that works. Now there's well, okay, it doesn't quite work. You type that into W count, it gives you 76. And I did accept this answer, even though there's, you know, some of these lines have the in it twice, and some of it has other words like there. If you want to take off other words that have the in it, just put a space, you know, after it's actually going to get them all. And what's wrong here? Oh, I didn't actually regenerate it. So now you see there's no more there's or anything like that in it. And if you got a dash O on this, then you get only the lines that had, or only the instances of the. And you put that into word count, 69 there, which that's okay. Some people have decided to go a little further and look in the man pages. I haven't talked about these man pages. I was pleased to see some people actually looked. There is an option up there, dash C. I haven't mentioned that in the slightest. This will give you the right answer. If you say grep for this dash C. Okay, and there we go, we got our 69. If you take out the space, you're going to get something higher. Okay, let's give it a dash O. The results should be a little higher there. Because I think we're still looking at the lines that contain that, and it's not quite the same thing. So anyway, there was some people did that instead of word count, and that was good. Dash V counts non-matching lines, as mentioned, and you can keep looking in here and find other stuff. Find you know, a certain number of things that match something or whatever. Okay, let me show you something funny you can do here. We'll start going beyond the assignment here. Okay. Okay, so when we count the poem, we got this poem here. And it's causing us a little bit of a problem here in terms of line matching, because when we grep for the, like that, you can see that some of these have two of them. Well, here's one approach to fixing it. I mentioned said in passing earlier, and like I said, I'm going beyond what I expect to know here. Search for a space, replace it with a new line everywhere you find it. Okay, now each word is on its own line, because we took all the spaces and replaced them with a move on to the next line character. If you've been in a Python class, /n might be familiar. If not, it's probably not. Anyway, \n is just a special way to write the character that goes on to the next line, because that's a hard one to write. You have to push enter, which moves you on to the next line. So anyway, you got them all on the right line. Now we grep for the. And we see it, including places where it's also in there. Okay, we'll look for a grep for the at the end of the line. And now we should have just a good list of the's. That's our prompt. And so I just push page down a few times. You can see they're all good matches. And now put that in the word count. That's the actual number of the's in the poem. And it's somewhat higher than the number of lines that have a the on them somewhere. Anyway, now you know. Okay, so, oh yeah, this next one, the one that ends up being 0. Verilog. Okay, so Verilog Apache 2, it's got this file access.log.1. Whoa, not good. Well, 644. There, now it's successful again. Okay, and you can see there's a lot of these things. And so we're looking in here for index.html. And we're not getting any results. Let's check the regular access.log just out of curiosity. Let's just change the permissions on all of them. Okay, now we can play with these. Okay, nothing in there either. Nothing with index. Nothing in this one. Okay. So logs evidently rolled over since I put a few entries in here to seed it with index.html. That happens. Let's instead look for people who have looked at the homework 3. Okay, there we go. So some people have looked for homework 3.html in here. That's great. Last one there, 13 September. Isn't it 14 September? Let's check access.log. Hey, there we go. That should be the current stuff. Finally rolled over to access.log. I should have done that a while ago. Okay, and so you can see a number of people have actually looked at it. If we want to know how many people, the IP address here on the request should be unique. So I showed you this trick earlier. Grep for the beginning of the line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a couple extra with dots and things. And you can see we mostly selected that. Put that into, I'll give that -O. Okay, there's a list of IP addresses that have looked at it. The dashes, incidentally, are about to not matter. And we can sort these, and we can put it into unique. And so the unique eliminates it, like whether there's a dash or not. What we're looking for is a unique marker here for a person. And so the dashes don't really affect that. And we can count those if we want to. So it looks like 15 people have looked at the homework 3. That's good. I don't know what the other 4 people in the class are thinking, but you know. 4 people have at least looked. Oh, actually one of those is probably me. Actually 2 of those might have been me. Me in my office checking to see if it worked, and me up here a moment ago. Okay, and some of those could have been the same person. Well, if you haven't looked at the homework, you should probably start it. Okay, so that's the answer number 3 there. Well, more than the answer number 3. Oh, how many files are in /etc, including subdirectories? Okay. Okay, so we do ls. We get a list of files and directories that are directly in this, and we put that into word count. We get this number 236. You notice over here I wrote find. Well, here's what find does. Find goes deeper into the subdirectories. And so, Apache 2 directory and files in it, but Apache 2 directory and then this conf available directory, I mean that's in there, and then the files inside that. So it essentially goes through the entire tree. And so if we wanted to answer the question, how many files have people stored on my software, probably give me a whole bunch of permission denied. We just go here and we find. instead of throwing permission denied a bunch of times, I just go back to /etc. Anyway, if you put that one into word count, you get a little bit larger number, 2475. In fact, there's a couple things we couldn't read there, and not very many apparently. So 2475 is like kind of the answer I was looking for. I think I accepted it with ls, but that's some different ways you might do it. Okay, and we get to, if you ls everything, you get one level in, which is not quite the right thing, but you do. Okay. Oh, and this last one.
How many did you get?
What's that?
You did find it 2475.
Yeah, 2475.
Didn't go as last week.
It may well have
5,000.
1,000? Probably not. Okay. Oh yeah. Display only the current IP address. Okay. This is the one that people actually miss some points on. Okay. So ifconfig gives us this. We're after that line up there, inet ADVR. And so I'll just use head and tail the whole time. Okay. Head-n2. That's head, 2 lines. So now we got the top 2 lines. Okay, let's take the bottom one of those. So now we've isolated the right line there. But now we need to isolate the part of it that we're looking for, this part right here. And so in order to do that, we'll just keep trimming here. So I want to take the first, I don't know, maybe 40? Oh, I didn't dash C40, sorry. That was too many. Let's go for, instead of 40, that was an extra 6, so let's go for 34. Okay, so you can see when I run this, I'm getting that part there. The prompt is ending up on the end, happens. And so then we want to take tail, -C, and then I think that's probably about 14 of them. Hey, got it right. Okay, so we got that. Now, we're not moving on to a new line, and so that's why the output to this thing looks all funny. And so one way to do that is pass it into grep for period, which will match anything. And there you go. So that's a reasonable answer. There's plenty of other answers I've seen to this. And so for example, some people took ifconfig and ran this into grep for the IP address. And so in order to grep for the IP address, don't put in the IP address itself, because that's going to be not work on different machines. And the IP address can change. Okay, it won't change on a software the entire time you're here, but the IP address is in general something that can change. If you're trying to run this on a different machine, we'll have a different IP address. Okay, probably. So we can grep for only, grep for inet. That'll give us these results here, which give us inet address and inet6. If we decide to include a space, we can actually get just the first one. If we pass a parameter here, eth0, we'll just get the configuration for eth0 and not for the local host. That would be fine. That's one way to do it. Another way to do it, so the one we want is not the one that has a 127.0.0.1 in it. Grep-b 127.0.0.1. That would give us everything that doesn't match that line. And that works pretty good. Now, the thing that some people are attempting to solve here is this issue that this has some 2-digit numbers in it here. Those could be 3 or they could be 1, depending on what machine you're on. You can see the localhost address here, 127.0.0.1. This has some single character ones here, and so the overall length is less than this one up here. And it would be nice to support both of these. Okay, so the next thing that I saw this done, this is clever. Use stream editor, which I haven't covered, I realize, and change inet ADVR : into a nothing. So you search for that, replace it with nothing everywhere. And so there you have just the IP address. Okay, so let's do some more stream editing and search for bcast and replace it with a new line everywhere it occurs. Okay. I need to put that in quotation marks because it got something funny happen to it. Okay, So now you can see this result we're getting. I realize that wraps over and makes it look funny. Basically that's the end of our command. And so we're getting this on one line, followed by this. So now we just want the first line. Okay, -n1. Okay, so now our giant long command there gets us just that. And if we don't like the space around it, search for space, replace with nothing, everywhere it's found. And there we have it. Okay, so now that entire thing is very, very long. It's going to be hard to remember. And if we would like to do this on a regular basis, maybe we want to save it. Cat into a file called, I don't know, IP only. Okay. And we want to cat all of this stuff into that file. Okay. So you can see this file contains this. We'll go ahead and add an instruction for the operating system on what to do with it. Run it in the shell. Okay, now we'll change the permissions. So it's executable. Now we'll run it. And now we have a command that works. Okay, well now suppose we're the system administrator and we want to install this. Because if we type IP only, well actually, I have wrote this, oh, I have dot on my path. Okay, let's go pretend to be somebody else. Who can I be? I'll be administrator. I'll be in my home directory. And I type IP only. Oh, it doesn't work because it's not installed for the entire system. Okay, so let's install this stuff. And we'll install it into user bin. Okay. Oh, and let's edit it a little bit. Call ifconfig completed. Because your call list didn't work with just ifconfig on a lot of your profiles. So there you go. Okay. So it should be installed. There we go. So now if you're on iSoftware, you just type IP only, and it will run the program. And if you want to see what it was, which IP only, well, it found it there. And if you want to cat that and print it out, you can do that. Remember the backtick slot from last time? It takes the result of this command here and puts it down right at that point. So by saying cat backtick which IP only backtick, what we're saying is cat this thing here, user bin IP only. And so it's like that, put it there, and then print the whole thing out. And there you have it. Okay, so that took it rather farther than you had to for the homework, but there you go. Okay, any question about the homework? Okay. I realized the answer was somewhere buried in my long explanation of everywhere you could get to from the question. Okay, so number 14, let's see, talk about that. Start homework 3 early. Oh, by the way, did homework 3, any questions on it at this point other than the missing explanation thing? Does this thing make sense?
Having a little bit of trouble with the searching within a range, but...
Searching within a range?
Number 3.
Oh, okay. Oh, yeah, so you want to know how many are numbered between 100 and 300. Yeah, so what you're looking to do is shell expand that area between 100 and 300, basically, to match everything in that range. And so, like last time, this example, okay. These were conveniently labeled like track whatever. And so if I want to list all the ones that are in a particular range, I can do something like ls everything followed by, say, a 0 followed by a, say, a 3 through 6 followed by anything. And so I'll get all the ones that were, like 3 through 6. And I realize these are all here. Let me go ahead and move one for a moment. Okay, so I'm going to get the results there, and including the missing one. Scroll to 8. Sure, there we go. And so we found all the ones that were in that range, and then we just run that into word count. And there's 5. Okay. If I move that one back, which I should probably do before I forget, then you can see the results went up to 6. Okay. Any questions? Okay. Okay, so hopefully that goes okay for you all. Oh, so today, shell variables. I like variables. Okay. So the idea behind a shell variable is something where you can store stuff in it. You can do that. But here's the grand point behind variables. So a variable is something that can change. And I was reading this web page the other day. I was curious what fraction of your food you actually exhale as CO2, and it sounds like most of it. Anybody wanted to know? Okay. So this guy who's a physicist and not a biologist, definitely not, put together this plan. And what it comes down to here is basically a loss of food at a constant rate. And so he makes a bunch of assumptions, and they're right in here. Okay, so he says we inhale air at 21% oxygen. Sure, that's not going to change a whole lot. And we exhale CO2 at 4 to 4.5% concentration, which reduces the pure oxygen. Obviously, it's still coming out as the O2 and the CO2. It's just combined with carbon now. And so he's assuming each breath is 1 liter in volume, and you have 10 breaths per minute. And so you exhale 1,720 liters of CO2 per day, which is 32 moles, which is 380 grams of carbon at 12 grams per mole, which is a constant. And that's enough food for about 2,000 kilocalories a day. So that's why I get pretty much all of it. Okay, a lot of these things are treated as constants in this calculation here. And he never goes through and undoes it. If you read this thing to the very end, he continues to use these assumptions all the way through. Well, these all change. If you are, say, you decide to hold your breath for a while, you're going to have a higher concentration of CO2 than 4 to 5%. If you're breathing hard, you're going to have a breath that's bigger than a liter. And of course, you're going to have a higher frequency than 10 per minute. So all of these things change based on your pattern of activity. And what he finally gets down to in the end is he says, well, if you want to lose weight, just eat less food. But he's sort of missing the point that your metabolism will slow down, which actually decreases the amount of CO2 that's exchanged with the air, and will probably subtly decrease your breathing rate, and will certainly decrease the concentration of CO2 you exhale. So basically, all of these things are actually variables. Well, in computer science, we call this a magic number, when you just take some number and you put it in something that it applies to everything in the entire world. And they're to be avoided. You probably heard about them by now if you're in one of the programming classes. If not, you have now. Okay, and you'll hear about them next time. So, variable implies something that can change, some way to adapt this thing to changing circumstances. Not using a variable, it just kind of makes something fixed on one particular outcome. We deal with variables and stuff that's not variable all the time, Your car has several gears and it can vary between them. It doesn't have a variable number of doors. You got to go buy a new one if you want to change that. Or get a chainsaw, there's constants and variables all over the world. And in computer science, we really like variables because they're easy to do. It's much harder to engineer a car with different numbers of doors depending on what day. I'm sure you could do it somehow, but it's not a usual feature. Computer science, it doesn't really matter. If they don't like the number of doors in a car, you just generate a new one, and that's the new one. Okay, so variables. Get to variables. So you can make variables in the shell here, and I am supposed to remember to not skip ahead to what variables are actually on there until I show you how to use them. So let's do that. We'll go ahead and set a variable. There's this command called export, new command for the day. This is one to actually remember. It'll be on the test. Okay, so you want to export something, say x, and it's going to be 9. Okay, we have to declare that x is now 9. And remember, echo just prints stuff out. And so we can say echo. If we just say x, it'll print out, x. But if we say $x, the shell will expand that. In this case, I guess it's a contraction, but we still call it a shell expanding this thing, and get a 9. And so we have managed to store that variable and to a value and bring it back. It doesn't have to be a number. So x equals, I don't know, ls. Okay, echo $x. Oh, that's that. Okay, let's run what comes back from echoing that. Hey, look, it's the ls command. So anyway, yeah, so the shell can expand all of this stuff. Echo, what comes back from echoing that? Well, that doesn't really change anything. Okay, so we can expand these things, and that works just fine. If we wanted to set this up here, export, say this is a variable content. We're going to have some issues. First problem is I used a single quotation mark here, so it's waiting for the match to that. I guess I pushed it tilde. So if I wanted to put this in quotation marks without hitting enter on the way, okay, echo $X. Now we're fine. Quotation marks in general protect stuff from special features. So that single quotation mark there, you expect a quotation mark and then something to end it. Well, I don't have one. And so I put the whole thing in double quotes, and that marked this as all just literal text. I don't need to do anything with it. In fact, that's how you do it if you wanted to put, say, the name of a variable in there. This is a variable's contents. This is $X's contents. Okay. Echo $X. Okay. Uh-oh, it did expand it. Sorry, maybe I have to escape that one. That worked. Okay, so the quotation marks apparently won't prevent the shell from expanding a variable. I learn something new every day. It expanded it here. Basically, it took the contents of X and stuck it right there. And so then when we echoed it, we had this is, and then this was the value X. And then we have the apostrophe as this contents. So over here, when I put the slash there, a slash is an escape character. You saw me use it with the slash n. It's just a tangent thing at the moment. But it'll come back with regular expressions and things. Anyway, slash just says that I'm going to type this character. Don't use its special meaning. Just put the character there. And so anyway, we did that there and did expand that. Okay. So you can set them with export like this. Incidentally, there's another way you can set these things if you just wanted it for one line. Export takes the variable and sets it in the shell here so future commands can use it. Another way to do this is to change it on one particular line. And that's going to be a little harder to observe. Let me show you. X equals nothing. That'll be the word nothing. Echo $X. Well, we didn't change it by saying X equals nothing. You notice that we also didn't cause any kind of a syntax error here. Like the shell took this, and it just didn't give us anything different. Well, here's why. So we take this line and we run it. We give it to the shell to be expanded, and it's going to put X's contents there. Then we run the program echo with the variable X set to nothing. But this variable has already been expanded. Echo doesn't even have the name of the variable there. And so it's going to give us back just whatever it had on the line there. Okay, let's write a quick script here. Echo X. Okay, so this the script here, we're going to echo $X. That's it. Okay, and this is to be run with the shell. Okay, so that's it. We're going to echo that thing, and I'll make it executable with the permissions. Okay. So when it runs, it prints out X's contents. Okay. Oh, look at that. But did it change in general? Nope. So if you want to have some command you run, and when you run the command, you want the variable to be set to something else, you can use this construct here. But if you refer to this variable, further out here, it's going to get expanded into the contents in the wider world, and not what you said right here. This is only within this command, like while it's running, this is changed for. And so in this case, while this command is running, X is equal to nothing. And so we run it here, and it prints out nothing. So to print out what's in echo X, it's right there, just that. Okay, does that make sense? Okay, lots of people seem to think it does. That's good. Okay, one other thing you can do with export. So if you typed export, and I just typed that and pressed enter, I didn't give it anything in particular I was exporting. It gives you a list of variables that have been exported. And so you can see all the variables that are already set on the system. And there's ours, there's x. And yeah, that's the value of it. So that gives you that stuff. Okay. So that's that. Oh yeah, finally, yeah, settings aren't persistent. Watch this. I'm going to log out of Isoptera. Okay, now I'm going to log back into Isoptera. Echo $x. Doesn't have any value now. And if you do one that doesn't exist, it won't be like this variable doesn't exist or something like that. It'll just expand to a nothing. And so in this case, we just echoed a nothing. Okay, so there you go. They're not persistent. You can set them if you want. There's this file bashrc. Let's ignore the rest of this stuff. And export x equals, this is a variable for a CS228 demo. Okay, there we go. Probably put that in quotation marks. It's full of spaces and things. Okay, exit. Connect to Isoptera. Echo $x. Wait, what? Did get in there, right? Okay, so it looks like we didn't actually end up running .bashrc. I didn't try that beforehand. I'm using .profile as my place to put stuff, which I was going to talk about later. I'll still talk about it later. We'll go ahead and stick this in here. Exit Isoptera, log back in, echo $x. Hey, there we go. Okay, so I had to remove that from the profile here. Talk about .profile versus .bashrc in a minute. Okay, trying to put you all into the modern world. You'll see later. Okay, so here's a special variable, and it's export, and I just want to show you this one. So I'll grep for ps1, and you can see we got this variable ps1, and it's set to kind of long, funny-looking string. So let's change it. Export ps1 equals monkey. Okay. Well, look at here. That's my prompt. I can still operate the system. And it's hard to see where I am because it doesn't, print out the working directory. But it works. I can run like, interactive commands, and that works. And yeah, we just changed the prompt. It's like a better prompt. There. That looks better. So PS1 controls what your prompt is. And if you set PS1 to be something in particular, it will change your prompt to be that thing. And there's some special characters in it. I don't really remember what they all are. I think like @u might be one. Oops. No, it's not @u. Maybe it's %u. I don't know. It's not really part of the lecture today. There's special characters you can put in there that have special meanings. And you can put in characters for colors and that kind of thing. If we're going there yet? Oh yeah, shell colors. Let's go to my home directory. Okay, so normally I set it to that long, crazy string of stuff that you saw. And most of this is for colors. The /u up there probably means user, and that probably means host. And I feel like there should be a path. Maybe it's /w. Let's try it. Okay. /w. Oh, tilde. Hey, look at that. We got a path in here. Okay. Perfect. So there's things that you can put in here that have particular meanings. Colors in here. So this whole thing right here, that's the color I have my username set to, green, I think. And so that's how you say green on the terminal. Okay. let's just take this little string right here, and we'll go ahead and paste it in here. Oh, I didn't even do it. Maybe it needs like more escaping. I don't know. Nah. Sometimes it works if you can just paste this stuff in here, but it's not liking it. Okay. Oh, I know. I got to echo it. It's like quotation marks. I'm trying to give it the color green here, so I start making stuff green, but I'm not thinking. That's fine. Whatever. Okay, so that's how you said that. Anyway, so that's all slightly tangent. I'm getting off course here. Okay, so you can put stuff in here and make your own custom prompt if you want to. I made this one like 10 years ago, and I still use it, and that's about all I know about it. So if you want to play with custom prompts, go for it. There's actually a chapter in the book that explains it. I haven't changed mine back. And so you can make ones like that. Oh yeah, so this whole .profile thing, I meant to explain where that comes from. There's a few different files that can be used to initialize your shell. And .bashrc, I think, is the one that's going to be doing it on your profiles. And we can go ahead and test that. Okay, I backed up my .bashrc and removed it. Now I'm going to log into my software. Okay, everything actually still works, which is a little odd. Maybe my bashrc is completely ignored. There's another one called bash profile. That's not on here. One called .profile that I'm actually using. And since we've just used it, let's go ahead and hide this one too. Okay. Hey, now I've got rid of all this stuff. So now when I log in, you can see that I'm not special anymore. Like my prompt is just normal. It's not colored. Okay, so if I want to change that, I think if I just make a new file, I create it called bashrc, it should work. Okay, ps1 equals monkey. Okay. Nope. Sorry. Oh. I did something silly. Actually, I stopped the log that I was trying to make. Okay. Should be back. So I got this I went and started changing things on the wrong machine, and this might be why stuff wasn't working right. So I should be more careful what machine I'm on. And if I confuse myself, I probably confused most of you too. Okay. .bashrc has that in it. .profile has nothing. Let's try changing it to .profile. Now it changes. Okay, let's try this. Move .profile to bash profile. Oh, and that gets run too. But apparently not .bashrc. So, let's summarize this stuff real quick. Okay, so .profile. This seems to be run at login. Okay, .bashrc. This is not run very often. And then .bash profile. Okay, this runs at login. According to our observations just now. So there you go. So anyway, if you want to make something appear or happen or whatnot, you can put it into your file, .profile or .bash profile, and that will happen. And so I think it should be still set up there. Yeah, it still is. Okay, I'm going to move my old one back. Profile. Dot back. I'm just going to move it back. Okay. Fix. No. Oh. Okay. Let's change this a little bit. Okay, if you have one of these, it seems to get run in preference to this. So now you know. Okay, so let's see. So now I don't have one. So according to my logical rules up there, that should happen. Good, excellent. Okay, .bash RC, I said not run much. I think it might get run on a virtual terminal. If I do on this this machine, Control F, that's a virtual terminal, and it can affect how login files are run. So it may run .bash RC in that case. I don't want to belabor the point too long. I do have other things I want to finish explaining here. So basically, the way I run things, I have .bash RC run .profile, and then if this gets run, it just runs that one, and I keep all my settings in .profile. I was going to encourage you not to do that, but it actually seems to be a pretty good idea looking at this stuff. .profile is kind of an obsolete name. It was used by shells that predate bash, but it still seems to be well supported. I figured it'd be falling out of favor by now. Okay, so .profile, good place to put all your settings apparently. In terms of what I mean by all the settings, so if you want to make a variable persistent, then you can just go ahead and export it right up here. And so I have PS1 up here, for example, for my prompt. Okay, well let's go on to another one. How about path? So this setting here, this whole $ path construction, this basically sets path to whatever's on the path and then adds on this other stuff. SBin, user SBin, tilde bin, which is my user's directory of executable stuff, GNA SRC, which is the graph neural analyzer, and /CS228, I'm not sure what's actually in there, and then a period. Maybe that's not even on here. Okay, so maybe that should be eliminated. But anyway, we look at that, we can echo $path, and we can see what else was on there too. So this is the search order when you're running a program. And look for the program in user local bin, bin, user local games, sbin, this is my addition here, sbin, user sbin, etc., etc. And finds the program along this path somewhere, then you can run it. Okay, so this whole path thing on here. Let's go ahead and try an experiment. Export $path equals nothing. Oh, excuse me, I don't need $. Path equals nothing. Okay. So if we look at $path, we see path is nothing. Okay, let's go try and list our files. No such file or directory on ls. Okay, pop, who, last. None of this stuff is going to be found. SSH? Nope. So that's because instead of searching, user local bin, etc., on this path, we're not giving it any spots to look for these commands at all. And so that's why we're not finding them. Okay, so in order to, let's go ahead and add something. Okay, first of all, I'll show you can actually run with another path. I think ls has been ls, and indeed it was. And if I do like bin who, is that what it is? User bin who? Oh, it's in user bin. And so I can, if I can find the file on my own without having the shell search for it, that's fine. I can still use it, but it's not going to look through the path for me. Path equals /bin. Okay, now ls is going to work. And that's fine. No CD works. CD actually worked all along because it's a shell built in and not a command that has to be searched for. And that works. Who does not work because that was in user bin. ifconfig doesn't work. Okay. I'm going to log out and log back in. as a quick way of restoring path and making it work again. And so now everything should work again. W last, IFTJ, everything's back. Okay, so that's what the path variable's for. Old PWD. Okay, here's one. Okay, so we echo $ old PWD. Right now it's home set. Okay, let's go somewhere. Okay, let's go somewhere else. Okay, let's take a look at it. /user. So I just went from /user to /temp. So my old working directory, where I used to be, is /user. And so that's what this old PWD variable is. And here's one thing it's used for. If you do cd dash, it goes back where you were. This could be handy. For example, suppose you went to user src Linux source 3.2, and then from here you wanted to go into FS, and from there you wanted to go into ext4, and then, oh, I need something for my home directory. Well, it'd be nice if I didn't have to type all that stuff in there to get back, right? So you cd dash, and I'm back. Okay, and so that's actually a pretty handy feature. Incidentally, tangent here, but maybe useful. Push D puts a directory onto the directory stack. So if I do push D and tilde, it will go back to my home directory here, and I can go, places and okay. I guess I didn't go anywhere else. Pop D, and now I'm back to where I was when I typed push D. You can make a whole stack of them that way. You can push D somewhere, push D somewhere else, and then you go back with top D. Okay, anyway, so this PWD thing. Metro $P old PWD. Okay, let's change it. Okay, now let's go back. Look at that. It went back where we said the old working directory was. And so that's what that thing is used for. Now, luckily, it's actually going to be restored because they just moved. And so if we echo it, it's right there. And in fact, if I wanted to, let's go back a minute. Okay, there we are, we're back here. Now I'm going to go over here and say I actually was looking for that directory. And so if I do old PWD, there it is. And that was the answer to something on homework 4. It's not as far as I know. I can go ahead and echo that and put it into a file homework 4. In fact, I can append it on the end if I don't want to remove whatever was in that file. Okay. There it is. Okay. So that's a variable. Display. Display is a good one. Display, I have to be on the local machine to show you anything interesting, probably. Why didn't this colorize? Oh, I messed up my dot profile or something. Okay, anyway, if I display something, it's going to appear on the screen. This is the expected behavior of a computer. So this is using a variable called display. Echo sign or display. Okay, display here is 0.0. Well, yeah, that's the first display on the system. If I drop out of here and I echo $display, well, there's not a display number here because we haven't got a display on Isoptera. Now, we don't have to not have a display on Isoptera. I think I've made something funny happen with the log. Let's just say -x Isoptera and echo $display. Hey, look at that. Now we've got something in the display variable, localhost 10. Display 10 on the localhost. Okay, what that is actually is a handle of forward applications to our display right here in this room. Now I'm going to have trouble actually displaying anything. The reason is most of the programs that I run, gedit or Google Chrome or whatever, even if I spell it right, aren't installed on Isoptera because it's not a machine people sit out and use. Well, rabbit holes usually go on pretty far in computer science. Let's go to another machine. Okay, so I did the same thing and went to my office computer. And if we take a look at this, I go $display. Well, we still got this this forwarding thing. Okay, this one has graphical programs. Not that one apparently. Hey, it has that one. That's a word processing program. So this is actually running in my office. And so if I hit like a file and open, this is the files from my machine at my office. Home on here, I got like class directories and stuff, and video drivers. So that can be kind of cool. It's how many people here use the Windows Remote Desktop feature? Nobody? Okay, if you like this remote control business, and you also use Microsoft Windows, it has a feature called Remote Desktop that will let you control your machine remotely. And it's graphical, because everything in Windows is graphical. And it'll let you do this. Okay, so now you know. So then, anyway, you can even do the same kind of thing, forwarding one thing to another place. Sometimes this doesn't work the very greatest in the entire world if you try to do something really complicated like a video game. At risk of messing up the display somehow. Okay, it went full screen on here, I think. I don't know where it is. Oh, it had a request too large. Okay, so don't try and play a video game over it. But you can do most stuff. You can actually run like OpenGL demos and things. I've done that before. It's just that the video game wants a little bit more interaction with the display system than is allowed across the network. Okay. It might be possible to get that to work with different parameters, but we won't spend forever on that. I just want to show you what display variable is used for. Okay, that's fine. Better. Actually, no, I want to get rid of that terminal. Okay, back to this. Oh yeah, sure. So this get used for other stuff too. I'm not going to go and shut down my X server and everything to do this. But here's an example. So NVIDIA, my favorite video card company, has these drivers for Linux, and they give you a pre-compiled driver. See, in computer science, we have source code, which is the part of the program you can read, and then it gets compiled into machine code, which the CPU can read. And you could go and analyze the machine code bit by bit and figure out what it does. But that's not usually the way people like to analyze things and figure out how they work. In fact, it's actually a pretty complicated procedure. So NVIDIA, when they make these video cards, they want to keep the driver that talks to their video card kind of secret, so that their competitors can't figure out what it does. And so anyway, they just distribute a compiled one. Well, you have to compile an interface to your kernel, and you have to use the right version of the compiler. And their package, for the longest time, looked at this variable called CC in order to figure out what version of GCC you wanted it to use. And you just go ahead and set that to the same version as your kernel was compiled with. They finally got rid of that nonsense, and it auto-detects now and figures it out for you. So I can't show you that anymore. It's going to be a great example, and I went to replicate it on my machine, and I was like, oh man, they fixed it. So anyway, it doesn't anymore. Incidentally, it's more an operating systems class issue, but whatever. Let's go to a computer that has NVIDIA hardware in it. eMessage prints out the kernel log stuff and spell it right. And if you direct for NVIDIA in here, you can see module license NVIDIA taints kernel. Yeah, that's what the kernel developers think of their binary. I know. So I'm running a tainted kernel. Our software is not, this kernel is not tainted. Grep-I taint. Not in there. It's pure kernel. Okay. This one in the room here. Oops. By ATI. The other major graphics company. Their driver also taints the kernel. Disabling lock debugging due to kernel taint. ATI is proprietary. ATI Technologies, Nuremberg, Germany, taints the kernel. Yeah. So anyway, that's kernel tainting for you. Oh yeah. So back to this stuff. I want to talk a little bit about living with Linux. Oh, and I forgot some examples last time. I was supposed to come back to them this time. We left in the middle of lecture with some of this stuff not having worked yet. I was going to generate a whole bunch of JPEG images from TIFF files. I should go show you that that actually does work. Okay. Okay, so I have these directories, and I think we actually fixed my web server last time too, which is part of what slowed us up. And if we went in here, there were these transmission electron microscope images, and they were all TIFFs. And if you click on a TIFF, it will download it for you, and then you can open it in a different program. But that's actually kind of a hassle compared to just being able to open the silly thing in your web browser right here. So we wanted to make JPEG images. The other thing is the JPEGs are not going to be 17 megabytes. And if somebody wants to browse this image collection on their phone, they're not going to appreciate 17 megabyte TIFFs. Okay, so let's go ahead and do some conversion. Okay, so over here we're in this 328.13 directory. 328, 3-28, yeah, that one. Okay, we got all these TIFFs. Well, I was going to do it just with shell commands, but instead I'm going to show you something I wrote that I think is a very fun program. It's called Run On All. And what Run On All does, there's the usage information. And it basically lets you multi-threaded, in a multi-threaded manner, run something on a bunch of images at the same time. Let me go ahead and log this into my software and run the, well, can't see very much of it. I was going to run the top processes thing, but maybe it's not of any use. Oh well. So I want to run this on all the TIFFs. Here's how Run On All works. You say Run On All, and then you can say the number of threads, number of processors you'd like to engage on this task. And you can see we got a bunch of different images here. So the divvying it up is easy. You just give one image to each processor. And if you got too many, some of the processors you're going to have to do two. But basically just divvy it up. Each processor gets its images, and off it goes. Okay, so I'm just going to say up to 24 threads. I don't think there's actually 24 pictures in here, so we're not going to use all of my software's processing power on this. And so then I want to filter it at -F up here. And I want to filter it for things that end in TIFF. Okay? And then I want to do -T, which doesn't really run the command. We'll really run it in a minute, but for the moment we're not going to. Okay, and then the command I want to run on it, convert. Okay, so we're getting there. We got convert here, and we're going to convert each of these things, but we didn't say what we're converting them into yet. We have to do that. And we can start putting a quotation mark around this to hold all this stuff together. Item here means the item we're at. And so it automatically gets appended to the end, but there's an option to not do that. And I think that's key, I. You'll see I. Suppress adding item to the end of the command line. Okay. Okay, so we got all of that. So we got our item there. Then we're going to have our item.jpg. Okay. So this is the series of commands that's all going to be run. And so we're going to say convert this one to that one .jpg. We still got the TIFF in there. We'll deal with that in a minute. But in general, that kind of covers it there. Okay. So let's take this whole thing here, and we'll take the -T out, and it'll run. I wanted to show you that it was loading the CPU up pretty heavily, but you're not going to be able to see it because it's going to be below the screen there. So let's go ahead and do it. Okay, so see it kind of hesitated for just a moment. I apparently used 17 processors, and then off it went. And it gave us some errors and things, but whatever, I think it worked. So we go refresh this. You can see we've now got for each of these a .jpg version. Okay. And it's not really like that lousy. It just was zoomed way in. So there we go. This is mouse neurons. I saw one called Grid Junk, and I want to see what it looks like. Oh yeah, it's got all this junk on this sample. I was trying to figure out what in the world was going on with all of this junk. It's not supposed to be there. Like that's the neural tissue in there, and yeah, I don't remember what it turned out to be.
Maybe got
anyway.
some dirt in its eye.
What's that?
Maybe got some dirt in its eye.
Yeah, I guess. Okay, so over here, we got all these things .jpg, and you see .tiff.jpg, which is kind of dorky. Name, search for TIFF.jpg replaced with JPEG everywhere it's found on all of the files. There we go. So now we got one.jpg. Now I got this directory JPEGs where, oh, maybe we made that last time. It doesn't have anything in it. Okay. Move everything JPEG into JPEGs. Okay. They're all moved. Over here, we look at JPEGs. And there we go. There they are. So now I've got all my unusual spot. Was it unusual? Oh, well, that's weird. Anyway, so now you can see all this stuff. Apparently I was working on mutant mice that day. The cone. They're folded into sample. That's what I was taking a picture of. Yeah, not great. Not great at all. How's that? That's okay. That's a trail of synaptic vesicles there, neurotransmission happening between two cells. Anyway, so there we go. That's that example. What do I got left? Just a few minutes. I won't go through and do all the examples from last time because I'm out of time. I think I needed to do CS there. Okay. So I was trying to finish out what I was saying last time. Didn't have that chance or really I don't use it all as much. Oh, well, I don't know what I'm talking about there. Oh, I know what I meant. That's a different point. That's a conclusion to something else. Any questions? Comments? No? Shell expansion makes sense? Variables make sense? Mm-hmm. Okay, good. So hopefully that'll be useful for you in some way. Let me talk about the future just a moment of this class and give you perspective of where we're at and where we're going. Okay, so we had Labor Day, and now we're on to this variables, processes, and process management and operating system structure. I'm going to talk about processes and process management next time. I've been wanting to, at some point, talk about kind of, living with Linux issues, like if you decide to install it on your own computer. And I'm just going to keep sticking on the end of my notes, and one day we'll get to it, sooner or later. So anyway, I got that kind of getting pushed along. Processes might not take all that long. There's not that much I want to say about them in this class. In CS 430, you get to learn a lot more about processes. I'll have like a full week of processes then. But for this class, you just have to learn how to manage them and turn them on and off and background them, things like that. Okay. Package management, installing programs and things. So I'll talk about that a little bit. You don't get to practice that one very much. I'll probably put together a compilation of questions in the homework that week that practice skills that I think people will probably lose points on the midterm. So that you practice and I'll get better scores. Because I can't let you go installing and removing packages on Isoptra. That would no end of chaos. So I'm just imagining the assignment. Log into Isoptra. Remove all the packages that are needed to make your friend do the homework. The first one that gets to the homework wins. Okay, use grep to figure out the most popular text editor and remove it from the system. Anyway, so I'll probably just have kind of getting ready for the test stuff. I realize the test is like way back here, but you can't just like cram the night before and get a good grade on the test. It has to be preparation all the way through. Networking, I'll do a little bit of networking scripts and things. Again, I can't let you turn the network interface off on Isoptra so nobody else can do their homework. But I want to talk about kind of how networks work and how to work within them, because a lot of times on when you're using Linux, you might be using a machine like Isoptra, where it's not sitting next to your desk. And so being able to work gracefully with a system that's nowhere near you is a big part of using Linux. And the other issue on here is getting yourself onto certain networks, which is hard to practice. Finding stuff, using find and archives and backups and stuff, that'll be fun. Regular expressions are really the next topic that people tend to get confused for a while on, and when they figure it out, they decide it's worth it. So I'm looking forward to that. And then after that, we're about done with learning the shell, and we learn how to script the shell, use Python. And don't get too concerned if you haven't had 111. Python well, first of all, Python's not a very hard language to use. But secondly, we're not going to be going into depth on software design on Python and let's go use objects and all that kind of stuff. It's more just like, oh, look, you can put these things into a line. The major skills on Python that we'll learn are how do you make a list of things, run a command on everything in the list, and perform some kind of editing on each thing in the list. Oh, and finally, use a command to figure out if you should do something or not do that thing. So that's the main things. And these aren't really taught in 111 exactly. I'll cover Python a little bit just to make sure that you'll be okay if you haven't had 111. Because I know probably at least half of you haven't had a 111. Actually, let me get a show of hands. How many people have not had 111?
I'm in one.
I'm in it.
Okay. Okay. How many people have already had 111 in the past? Okay. How many people haven't even thought about 111? No? Okay. Okay. Well, I think I got... Okay, let's do this in a more straightforward manner. How many people could write a program in Python that does something simple? Oh. Well, that's pretty good. Well, that wasn't everybody, so you still got to learn it again. But we'll throw in some stuff you haven't learned. I can always throw in some extra stuff, Okay. Yeah, let me actually show you something real quick. Okay. This is a program written in Python. And this is actually run on all. And so the way you run something, basic form here. Why is the tab space set funny? Something's funny about my tab space. And I'm getting lost inside my own program. There we go. Oh, now it makes sense. Okay. Well, it should now, maybe. Makes sense to me now. Okay. So the basic thing you add to Python, whether you know Python or you don't, the way you run a command in Python is you run get output, and then you put your command together. Plus, in Python, stick strings together. And so we're going to stick together whatever the parameter -d was on this program with ls here. It stands for directory. It's the directory you're going to run all on. And you just mash the whole thing together into a command, and then run it on the shell. It's that simple. And then you get back a string, whatever came back for your command, and you put that in a variable, and then you can use it later. And so anyway, that's the basic of how it works. And so then you can write some kind of list or some kind of a loop here that's for everything you have in your command lines. Go through and run them. This one's convoluted because it tries to run stuff in a multi-threaded manner. Well, this probably does. And so it has to do some other stuff. System also runs a command. The difference between system and get output. System runs your command and then the output prints out. Get output runs it and gives you back the output in the program so that you can stuff it in a variable and use it later. Oh, anyway, so it's kind of should be just an extension on that, and if not, I mean the level of Python that we use is like if statements and loops for scripts. Here's the alternative. Bash actually will support scripts that have things like if statements in them, and it has a particular syntax. Let me see if I can find one. There's the one that I wrote so I actually understand it. It's on my laptop. Sorry, not everybody's like, time to go, but Okay, here's bash script. And so you say stuff like if whatever and then and that kind of thing. $1 is the first parameter that the script was given. Bracket is actually a program that you can run, bracket. And in our case, it told us that it was missing something. 4 equal to 5. And now we just echo $, question mark, 1. Okay, 1 means that it wasn't true. 0. So you can actually use this thing with if in order to start writing programs. And I don't know, it's kind of fun. But everything in the syntax is different than it is in Python. Like if you want to say if something, you say if. You use the bracket program for your condition. You can see we're using $1. That's parameter 1. if that's the same thing as dash W, then, and then phi ends the block. In Python, you wouldn't put phi at all. You just use the indentation. But bash, you have to say phi. And here's another one. If all that stuff, sending the output to dev null because we don't want to print it out, then do that stuff. Phi ends the if here. And you can have like else's and most stuff in there. But it is kind of a different programming language at that point. So when I was thinking about teaching this, it's kind of like, well, I don't really want to throw another programming language in. You can do all that stuff in Python. It's probably easier. A lot of people are going to leverage existing Python skills. And if you're not leveraging them, then you're learning them and getting a leg up on CS 111. So, that's why I went that direction. I feel a little bad because Bash is like the craziest language ever, and it's got all these weird rules and things, and it confuses people, and so you should enjoy it. But anyway, I decided to skip it. Okay, if you really want to learn how to write Bash scripts, your text actually tells you how. Okay, I guess that's it. You can finally go. Sorry, 53 minutes over. You could have left if you wanted. That stuff is on test.
So,
You trying to do it?
over 5?
Yeah, no, I'm trying.